Hello, everybody. This is Win Harden with Manufacturing Matters. How are you doing? We're doing another live broadcast from the A3 Forum in Orlando, Florida this year. And I happen to be with Jason Cross and Jeffrey Clark of Chroma Technologies. And now we're going to talk a little bit of one of the redheaded stepchild, which I can say, because if you see in the beard, there's still a couple of red hairs left, of the machine vision component space. When we talk about optical filters, lights, and those, a lot of times it can be the last part that a designer is going to choose and select before he's going to build his final system. Yeah. And which is ironic, really, right? Because the truth is that the more efficient we are in how we handle light for a machine vision solution, the much easier it is in our algorithms, the better, more chances for success that we're going to have. So a lot of you folks out there might not be familiar with the nuance of the different types of optical filters used in machine vision and advanced imaging systems. So you're going to get some great information from Jason and Jeffrey. So thanks for joining me today, guys. I really appreciate it.
Good morning. Thank you.
Good morning. Thanks.
Have you had a good show?
Yes, it's been great.
Yeah. How was the networking event? I know before we get down to business and start talking about, last night was the big sports networking event at the A3 Business Forum. And if you've never been, it's a good time. Everyone gets to wear their favorite jersey, and there's a lot of fun activities for us to do.
Yeah.
It was a lot of fun. I wore my Eagles jersey and got harassed by many people, which is just fine because it was a way to meet people one way or the other. So.
Plus, it made you feel like you were at home.
That's right, exactly.
So it's like being back in Philly. Constant harassment. Fantastic. So, Jason, why don't you kick us off and tell us a little about Chroma Technologies, an employee-owned company up in Vermont, by the way.
Yes. So, Chroma was started in 1991 in Vermont. The founders saw a need in the optical filter market for a specific application, which at that time was fluorescence microscopy. And what they realized was that for that market, signal to noise was very important. So getting rid of unwanted light, having a high degree of blocking unwanted light was just as important as having transmission of the light you wanted to see. Right. Especially in a fluorescence application, you're shining a bright light on something and you're looking at maybe many fewer photons coming from the cell or the target in the cell. So getting rid of that unwanted light was really important. And it was kind of revolutionary. Yeah. It made it so scientists could see what they wanted to see better. And got us in the door with fluorescence microscope companies on the OEM side very quickly. Right. And was a really quick boost, a quick growth. But another thing that they realized is that we were probably the first company to make, specifically for microscopy, a multi-band filter. So you could see multiple wavelengths of light and get rid of multiple wavelengths of unwanted light at the same time, which led to a revolution in biology, because scientists can now see multiple targets within the cell live at one time, or to a camera at one time. So that was a big deal. And we'll circle back around to that, because that multiband technology, I think, has uses in machine vision from what we've been seeing and hearing from talking to people.
Oh, I hear you.
The third component I think that we learned from that market is that application support was super important. While there were a lot of other places to go get optical filters, not all of them had or concentrated on application support and really trying to listen to scientists and listen to the manufacturers to guide them in how to make a better instrument. So that we learned from that market. Right. There we grew to other markets. We rode the fluorescence wave, mostly on the science side initially, flow cytometry, which is another thing. And most recently was for real-time PCR machines, which for COVID testing. So the idea being that we had a very robust, high performance, high signal to noise product is something that we've grown with for years. And out of that coming up with a machine vision line of filters. Because we saw the need there, and a lot of the similarities from what we were doing in fluorescence could also be applied to this market. Right. And from that, within that growth, or just to tie up where we're at now, we're about 200 employees, and we have sales offices in Germany, China, and Japan, and a sister company that makes instrumentation in northern Vermont called 89 North. Right. So once again, they're more on the scientific side, not so much industrial yet. I don't know if you wanted to put anything else in there.
Well,
about...
for 89 North, they're also an engineering firm. So if a company comes to Chroma and needs some types of holders for filters or light sources or modules, things of that nature, we'll reach out to them and they help us facilitate an answer for that customer.
Fantastic. So I know this, but as you mentioned very briefly, Chroma was one of the unsung heroes of the COVID pandemic. And at that time, I think you guys were going at least 2 shifts. Did you ever get up to a 3 shift?
We actually expanded directly into the weekend shift. So we actually had basically 24/7 coverage.
24/7
Operating
coverage.
systems, yes.
Yeah, providing filters for embedded systems for high volume blood testing, PCR testing, call it chromase reaction. Help me with the PCR acronym. Okay, it's the thing that makes sure you don't got COVID, and that which is really important. Yeah. But so this, working with some of the largest testing instrument makers in the United States and around the world.
Around the world, yeah.
So, we should all say a quick thank you to the little guys, and I think there's more than just Chroma Technologies in this space. You've got sensors and other folks who are helping to keep the world a little bit safer and healthier during that time. So.
And I want to touch upon that, the customer support. So as Jason mentioned, we're 100% employee owned.
Right.
So the person on the phone answering the call from the customer is an owner of the company.
Right.
So yeah, it's, we're all entrepreneurs, I guess, at Chroma, making sure that we follow up if there's any issues, but ultimately getting the customer what they need.
And that consultative sale, that ability to work with customers, as you mentioned early on in the scientific and fluorescence, Raman spectroscopy and other areas, absolutely critical. But as you develop the company and as these technologies, these imaging modalities, these fluorescent systems became more and more pronounced, you knew which chlorophore you were going for, right? You knew which waveband you really needed to target on based on what the trends were in that scientific instrument space. When it comes to machine vision, defining those key bands and wavelengths is a little more difficult. It's going to be more application specific. So I would guess that consultative engineering sale that you guys offer is even more critical for the machine vision integrators and/or end users who might be out there trying to buy your product now.
I think, and that's what we have. That's what we're learning is that the breadth of applications is just enormous.
Right.
I mean, and one way that we really fit in that mold, though, is that we can make filters all the way from like 220 nanometers, so from the UV out to the SWIR. So having a wide range of filters in that arena, we make some specifically for machine vision, some aren't, but just having that whole catalog of optical designs across that whole range. We know that we can help an end user probably find what ultimately is going to be the best for their machine vision application to give them best signal to noise and best rejection of unwanted light.
So actually that brings up the filter kit here. It's a visible regions. There's, 18 filters in here. Basically it's 20 nanometers and 40 nanometers wide, hitting all the known LEDs that's out there.
Right.
But if the answer is not within this box for the integrator, we can do custom. Again, what Jason said, 220 nanometers up through the SWIR region.
Right.
We have 30 years of inventory for other applications. We might already have the answer within our facility.
Exactly.
So, just give us a call and we're able to look through what we have in inventory and find the solution there.
So this is the Contrast Max line of machine vision filters, if I'm not mistaken.
Yes.
Okay, fantastic. So tell us a little bit what is different about your approach. There's a couple of different primary filter designs out there. Deposition type, dope glass, and tell us a little more about Jeffrey.
Sure. Well, when Chroma did begin making optical filters, we used the dope glass, the absorption glass. Because of ROHS, or ROHS, which is a criteria of trying to get rid of some materials, we switched our thin film design to compensate for what the absorption glass was doing. Basically, when you have signals coming in on an angle, you want to make sure that you're able to block those photons. We're able to do that with our sputter technology, our thin film design. So we compensate for that unwanted light in our thin film design, so we don't need the absorption glass.
Fantastic. So are all deposition filters made alike?
Well, I do know that for the fluorescence filters, we're not, for a microscope, we're not necessarily worried about that. that scattered or off-axis light, right? Because it's the light's coming straight up through the objective. So those filters can be even a little steeper, and we don't necessarily accommodate for the cone angle issue that you could have. So the machine vision filters are specifically designed because we don't know where that light's coming from. We don't know from your camera and your inspection system to where the sample is, you know, exactly what angle of light's coming at. So there are two different strategies, but it is nice to have both things available. And what we've learned is that, or I've learned in this market, is that I've been selling stuff for microscopes for 25 years, right? Basically, in that mode is I need to ask the end user what the light source is, what the sample is, and where the camera is. It's the same thing in machine vision. I'm like, oh, I'm already an expert at this, right? Because because it's very similar. I think having the breadth of designs actually is an advantage for us. I will go back to another thing that I think is very important about the Contrast Max filters and using this sputtered filter technology is that the coatings are very hard and very durable. So, and I'm pretty sure, are the only company that offers lifetime warranty on our. So, in an industrial environment, doesn't count a scratch or whatever, but for environmental stuff, for temperature, for humidity, we are the only company, I'm pretty sure, that offers a lifetime warranty because the filters are so durable, and which is a big, especially when the filters. In a microscope, all the filters or some of these other instruments, some filters inside, but in this case, right, sometimes the filter is outside on the lens, right out there with everybody else. Right, exactly. So I think the lifetime warranty is a big selling point that I've been using.
That hardness is really critical for industrial and real world applications outside of the lab. So it's nice to be able to have scientific precision that we can take to an industrial application space.
Correct.
That's critical. And you know, to have, as you said, equal slopes on each side, so we've got just the right amount. You guys, I think OD 3 or 4 in terms of level of blocking.
Oh, easy, yes, for the contrast mass, yes.
Contrast mass. But that level is more than sufficient for the kind of blocking that machine vision applications want to be able to provide maximum contrast, resulting in maximum modulation transfer function, which means that you're getting cleaner images, higher throughput for your machine vision system, which makes it easier on the designer, right?
Yeah.
Because the better your light handling is, the less you have to do on your algorithm side to optimize your system. So it just makes it easier all the way across the board. And when you're considering that you can get that precision for essentially the same cost as you're buying other units from the currently in the marketplace today, you just have to ask yourself, well, why wouldn't I go the best if it all costs the same?
I do think one thing that I've learned from is, or what we're focusing on, and I think some of the other filter manufacturers are, because of the advancements in the technology for SWIR components. So SWIR light sources, SWIR detectors. Focusing in that market is interesting because a lot of the materials or things that you're looking at have a totally different response in the SWIR versus the visible. So the absorption's different, the reflection's different. And so we think that that's a really important and exciting avenue. And we offer a wide range of filters in that range too. One of them being, and I said I'd circle back around to it, is the multiband filter. So an example, I mean, because I know sometimes in these inspection or automation issues, you want to go faster, right? Everybody wants more speed. More speed saves time, saves money. But what you can do, what we've had some customers do with the multiband filters, if you have a multiband light source and you can trigger sequentially the different LED channels, you can have the one filter there in front of your camera. So you don't have to have anything mechanical. So you can actually save money and time and go faster by having maybe one filter versus 4 and a filter wheel or something else.
Which is another point of failure anyway.
Yeah, exactly.
Nobody likes to have mechanical. We'd rather have a fanless camera if we can. There's just the fewer moving parts, the better. Solid state is much more rugged for so many applications.
So I think that's a real major player, and I think at this time, we're one of the only people that offer the multiband SWIR filters.
And one of the things that is most exciting to me in that space particularly is that the camera costs are finally starting to come down. We've got Sony's new sensors, which are copper to InGaAs, I believe, and, which I mean, it's mainly silicon based, so we're pretty much coming into cost parity for the actual sensor to a standard, say at least a CCD level, if not a CMOS level. And at the same time, we've got the quantum dot SWIR cameras from SWIR, I think, Vision Solutions that's coming out. So both of those offer the ability to take us out of the $15,000, $20,000 camera and up and bring this SWIR technology into something much closer to, say, a 12 megapixel camera, a visible camera, something that we're regularly selling and using into the marketplace. So that's fantastic.
I'd like to make one more point on the filter kit too, which is a real advantage. As we said, it's a way for well, 2 points. One is a way for you to start narrowing down what wavelength region might be more helpful for you, right?
Yeah.
And as we said, there's different widths, both 20 nanometers wide and 40 nanometers wide. But it also gives me the chance to, if one of those is made things better, maybe we can go narrower and make it way better. So talking about custom filters is something that we do all the time. So we're not just a catalog company. It's not just what is listed in our machine vision inventory. We can make custom filters, and historically we have not charged that. We try to make it very affordable. So it's not cost prohibitive, and sometimes it can make a big difference. If we go down that path and see if we can find that exact filter for your needs.
Especially for embedded systems, high volume embedded type
systems. That's easy. Yeah. So
which has kind of been part of in your bailiwick, your area for so many years.
And I have, so the second point is on these kits, they are available for sale, and we made them for the number of filters in there very affordable. And the idea of the use of the kit and the box is you can either have it in your lab, in integration lab, keep it under the shelf, bring it out, put it in front of the camera. If customers send you a sample, you can also take it to site. In working with integrators, I've been sending these out to people to try to see if I can help solve problems. So if you would like to try one out, you can just contact me.
So what's the website again?
Well, the website is www.chroma.com, and there's a machine vision link, but probably specifically sending me an email. Because I'm the one currently pushing the market right now and getting these out to people and starting to work with people.
Well, you can find out more about the whole Contrast Max line there, and you can get in contact with Jason by swinging by their website. And Jeffrey, any closing thoughts?
No, I think just the main thing that we offer catalog product, but also capability of doing custom work for specific applications.
For the designers out there, the machine vision integrators, if you've got a tough application and your light budget is tight, doing a quick free consult with these guys just seems to make all the sense in the world. That one little part of the solution that you haven't been able to master, a small filter might be the solution for it. So, Jeffrey, Jason, thank you so much for your time, guys. I hope you had a great time in Orlando, and enjoy some of the warmth before you head back up to North Carolina and Vermont.
Yeah.
So thanks for joining us on Manufacturing Matters, everyone. Until our next episode, have a great day.